Hello everyone, and welcome to today's installment of our technical webinar series. Today's webinar is called A Smarter Way to Create a BIM Model for Bridges and Structures. My name is Frank Holtz, and I'll be presenting today. I am a senior technical consultant at ALLPLAN. I have a bachelor's and master's in civil engineering with an emphasis on structures and structural materials from the University of South Florida. I've been in this industry for 7 years now, the first 4 years of which I worked as a structural engineering designer, designing mostly precast, pre-stressed bridges, but also other structures and structural materials. Then I spent a few years actually developing structural engineering software. This is computer-aided engineering software that helped engineers design a whole range of precast structures. Looking at the agenda today, after our introductions, we'll get right into it, look at a workflow for bridge modeling inside of ALLPLAN or in general. Then we'll cover how to handle reinforcement of a bridge structure, including PT, pre-tension, and regular reinforcement. And then most importantly, how do you get the drawings, schedules, and other kinds of reports out of that. After we've covered all that, we'll talk a little bit about ourselves, ALLPLAN, and the group that we belong to, the Nemetschek company. And then, like I said, we'll get into question and answers and wrap it up at that point. All right, so before we begin, I'd just like to talk a little bit about what we're going over. Today it's going to be mostly, our focus is going to be on bridges. As you can see here, we have a wide range of bridges that have been designed in ALLPLAN. These are some of the more complex bridges, but in order to realize the benefits of ALLPLAN, your project doesn't necessarily need to be as complex. We do the full range from very simple parametric bread and butter bridges all the way to the more complex bridges that you see on your screen right here. Not only do we cover bridges, we cover buildings and we cover them well, and we also cover a wide variety of them, including all kinds of building materials. Let's not forget heavy civils. Our expertise in modeling alignments lends itself well to other linear structures like tunnels. We also do water structures, offshore structures, excavation, drainage, you name it, we can handle it. Rebar detailing, this is what we do the best in industry. We handle all kinds of reinforcement, like we said, not just rebar, but also rebar that's near post-tensioning. We do the post-tensioning itself. We can also deal with projecting, embedding at cold joints. We have built-in support for splice sleeves and couplers. And then when that reinforcement gets around other things like anchor bolts, we do that as well. You're seeing a lot of 3D models here, but one of the strengths of ALLPLAN is that you get to continue working in your 2D sections, not only because it's easier for the workforce because that's the skills they currently have, but also because documentation is really the key to construction. It is the essence of what we do, and that's why one of the reasons we make it our main focus at ALLPLAN. So you're doing a lot of work in 2D, you're maintaining your 2D workflows, and your model is not necessarily a byproduct, but it can feel like that's a byproduct of the work that you're doing in 2D. Because designs are still built from drawings, if we realize that. Everything that's constructed needs to be put onto a drawing so that it can be handed off to the people who are actually going to be building this. The model is important, however, for producing the schedules and guaranteeing that the details are correct. So that's important as well. First, we're going to take a little bit of a look at the workflow for bridge modeling. It's pretty standard across anybody who's using BIM or just doing designs in general. Before you really can begin, you have to get your product set up and mobilized. Once you've organized the project, you brought in other trades, other contractors, other engineers, then you can start to actually look at the project itself. You're going to want to set up your boundary conditions. This includes survey data and other constraints that need to be identified before alignments can be drawn. ALLPLAN has a wide tool set dedicated to digital terrain modeling and alignments. Once you've created your horizontal alignment and your vertical alignment, I'm going to show you today how easy it is to create that into a 3D alignment. And some of this work, especially in the beginning, can be done by other softwares and then brought into ALLPLAN. ALLPLAN is open BIM, as you'll see later. We work with many exchange formats. Currently we support 11 types of import, 50 types of export, and we also support linking and embedding to Microsoft documents as well. The second part of it, after you've got the setup done, is to actually model the bridge. There's a number of ways you can take. You can start, one path is to go from the top down, which involves looking at the superstructure, modeling your deck, the structure that supports it like your beams, and then the bearings. Another option is to go from the bottom up, starting at the substructure with your foundations, abutments, piers, columns, what have you. A nice thing about this is the work can be split across teams thanks to our multi-user approach. Those teams can be in the same office or they can be around the globe using our ALLPLAN share functionality. And again, some of the work doesn't even need to be done here in ALLPLAN. You can do it in other softwares as well and then bring it into ALLPLAN. But we would hope that you do it in ALLPLAN. The next main section of the workflow for bridge modeling, this is where we really do shine. Engineering has been considered at other stages in the process previous to this, but this is where the engineering really starts coming into play. Once you got your model created, you can then populate it with reinforcement, post-tensioning, pre-tensioning, and then you can start to develop or generate your schedules and reports. And the nice thing about having the model is when any changes occur, your schedules and your reports are going to get updated as well for you. With all these pieces, now you can start to put together the puzzle that is drawings. That's what you think of when you're doing layouts and bringing viewports onto your different paper spaces and whatnot. And it doesn't end there. After you've created these drawings, you don't just hand them off to other people and you're done with it. You have to coordinate with other trades and specialties and contractors. We have a few ways of doing that. The first is BIM Plus. This is great for coordinating with the other trades, anybody who's dealing with signs or signals or utilities. There's a lot of things that go on bridges that aren't just trucks and cars, and BIM Plus is the tool for that. Another tool is Celibri. This is one of our sister companies. It's a great rule-based system. It helps you to combine up different models that are involved. You can check for constructability. It's important to remember, just because you can model it and draw it doesn't mean it necessarily can be constructed. Another great feature of Celibri is to add in all the attribute data. Again, another rule-based system just for making sure you've got as much data as you can have in there. Finally, we don't only have a rich history for many years, we're also looking into the future. That involves virtual reality, artificial intelligence, and making things as parametric as possible in the future. All right, so we'll get right into it, and we're going to take a look at ALLPLAN in action. We got a series of videos here that I'm going to talk over. The first one involves 2D alignment. It's pretty straightforward. So here we have a horizontal alignment. It's made up of a series of arcs and straights, and what we're going to want to do is go ahead and combine those into a spiral, which is just a series of those arcs and straights combined together. And then we'll actually turn this into a composite element for ALLPLAN to use. After that, we'll be able to apply stationing information. This can be done piecemeal, or you can do the entire length of it. You can set a regular spacing, or you can define discrete locations for your stationing. That's important because the next thing we can do using some more tools of ALLPLAN is to run some analysis on it to generate some interesting labels. The first of which is a curve trace. This is really handy. It helps you map out what radius you're looking at, how long your straights are, and at what station all those things are occurring. The last one is a torsional trace. This is really handy. It calculates based on centrifugal forces as that truck drives around the curve, including their speed and everything else, to determine a cross slope that you need in order to counteract those centrifugal forces. Now that we have our horizontal alignment mapped out, we're going to go ahead and combine that with our 3D, with our vertical alignment to make it into a 3D curve. So here we're just going to go over, copy that horizontal alignment in 2D, get rid of some of the extra information that we don't necessarily need. And then with one of the tools in ALLPLAN, we're going to go ahead and combine the 2D horizontal curvature with the 2D vertical curvature and make a 3D alignment for our project. Here we can see it's just as simple as selecting the two items and executing the tool, and they will now be combined up in 3 dimensions. So we'll flip over to our animation view, get an isometric look, and then spinning around that new object in space, you can see it's exactly what we wanted. We got our 3D alignment and our vertical alignment and our horizontal alignment combined together to give us a nice 3D shape. The next part of that, after you have your alignment completed, is to go ahead and start modeling the structure. We're not going to use a curved alignment here, we're just going to use a straight alignment to keep everything simple in your mind. So we have a 2D cross section in plan, and we've just created an alignment which is essentially a straight line. Before we can begin, we're going to convert that 2D section in plan and convert it into a 3D object. This will allow us to rotate it in space. First, we're creating individual objects for the tub beams and the deck itself. And now we'll actually begin the rotate command. Now when we bump out into isometric, you can see that our 2D cross section is aligned properly with our alignment, which is a straight line. And we'll go ahead and begin the extrusion process just by selecting a section and then selecting the path, and we've extruded that deck. Now you notice we only needed one path in order to get the extrusion working. We can actually use the lines of the deck that we've created in 3D to work as the path for the extrusion of our tub sections. And rotating that around that in space, it looks exactly like we expect. This is a pretty straight rectangular bridge. We can deal with skews simply by using Boolean operations at the end or using some more advanced features. Here we're just showing you how simple it is to go and apply texture surfaces. It's a nice drag and drop operation, not too complex. Just simply select the texture you want and bring it to the item that you want to apply it to. Now that we have that 3D model established, we're going to go ahead and do some simple reinforcement here. The first step is to go and create a view or a section. And we'll drop that in our plan, line it up with our plan view, and we can go ahead and give it a label automatically, and now we're ready to start placing reinforcement inside of that section. We're going to begin by selecting the bar shape tool to create our bar shape. We're going to be doing some straight bars, but they don't need to be straight bars. They can be curved, freeform, L-shaped. We have a whole series of different bar shapes available to you, and if any of those don't work, like I said, we have the freeform available. Once we've placed a bar in our cross section, we'll go ahead and run it along the length of the bridge. We have some different options. We can show all the bars, we can shoot one of the bars. You can see the parameters on the side for actually adjusting the bars. Of course, where you have a matte reinforcement like this in a deck, you wouldn't want to show every bar, so we'll just choose to show a single bar. And then ALLPLAN, another thing I really like about ALLPLAN is it's always trying to predict what you want to do next. So after you shape a bar, you place the bar, it'll ask you how you want to label it. So it's a really great feature of ALLPLAN. Now we're going to place some longitudinal bars on the same methodology, and we can actually use our previous bar to define the alignment properties for those bars in 3D space. So you can see those all exist there. We'll go ahead and give it a dimension string and place that alongside, and at any time in the process you can go back and change things. So here we'll just change our bar to have it display not all over the place, but just have a single display placement. And now going into 3D and animation view, we see that all the bars are exactly where we expect them to be, placed accordingly. Next up, we're going to do a little more modeling, this time with our loft command. This is a great tool if you have some geometry that you really need to hold tight. So everywhere you define a cross section, you can guarantee that it's going to be exactly what you had drawn in that 2D section. Using the loft tool, we'll go ahead and create a section of the deck on the left, and then create the sections for the openings, the voids in the middle. Again, using the loft command, and we'll just copy those over to the deck on the left, and then using our Boolean tools, in this case a differencing tool, we'll go ahead and cut the voids out of the bridge. As I said, loft is a great tool for maintaining your geometry. Wherever you have a section defined, it will be exactly as you defined it. There's a lot of work on the front end, but you have complete control over the section, which is really handy in some cases. Next up, we're going to be looking at the variable sweep tool. This is great if you want to relinquish a little control and make your work a little more efficient by specifying just a few cross sections and some 3D splines. You're able to create that 3D geometry much more quickly. Now, it's important to remember the more control you give the computer, the less control you have as a human. So sections of it may not be exactly as wide as it should be based on however the spline data works. But like I said, if you need to maintain that tight control, you can do loft. You can go a little bit finer detail actually with the sweep path is by specifying some more splines along the length of it and then using that to control your geometry right out. Here we see that we've selected some cross sections and now we're selecting splines that go at the vertices in those cross sections, and that will control it so that they fall exactly where those splines are. Still not as much control as a loft, but it does give you more efficiency and lets you create things quicker and easier. Here again, we're just creating the voids as solid objects, and then we're going to go ahead and use those to difference them from the main geometry body. Flipping over to animation, we can see that it is exactly as we expect once we go ahead and perform the cut operation. And now we have our bridge with nice slopes and curves, no jagged edges, and it will be produced quickly and efficiently. Next tool we're going to look at is sweep bars along a curve. This is a great tool for putting reinforcement in once you have your model established. Here again, essentially it's requiring some cross sections and some splines. So we have our modeled bridge, we went and cut some sections out of it, and then we've modeled some reinforcement inside of those sections. Again, it's the same 2D workflow you've already been using, except we provide some tools to make that workflow a little easier. So here we've selected the transverse reinforcement, and then going back to our 3D model, we're going to select some splines, some control points. You can choose as many as you want, but you really only need to select as many as you need in order to control whatever geometry is changing along the length of the bridge. In this case, we have the depth of the beam is increasing as it gets closer to the midspan, in which case you're going to want the height of that transverse reinforcement to increase as well. And you can see here it's doing exactly just that. At the ends of your girders, you know that you have a little higher shear, so you need to decrease the spacing or maybe increase the size of your bars at the ends. And so for that we have region support. So you can supply additional regions. All you have to enter is the length of the region and the spacing of the region, and the model will adapt accordingly. Here you can see that we have 16-inch spacing towards the center. We bring that down to 8, and then looking at our 3D model, well, we just upped it to 1 foot, but you can see that it's adjusted accordingly. Our last video is going to look at creating sections along paths and doing some PT modeling. There's a few different ways you can handle this. You can do a less sophisticated method, which we're going to cover first. This is just simply taking some splines and a circular cross section and combining those up just to create the generic 3D object. It's not going to have any information attached. It's not using our special PT modeling tools, which are really powerful. But it's a great way if you don't have a lot of information, you just want to kind of check some geometry to go ahead and get that in there as well. And so you can see we're just defining a circle along the length of that spline. We'll go ahead and put it at the end of the spline, create it to the diameter of our liking, and then go ahead and use our extrude tool to run that along the path. And once we execute that, you'll be able to see that it's following that profile correctly. Just got to be sure that we click the profile and then the path, and now it's modeled in 3D. So a great way to get some more information with your model, even if you don't have a whole lot to begin with. You can definitely start checking some of that stuff here, and of course they'll show up in any section that you generate as well. I'm going to skip ahead a little bit here. Alright, so the next thing up, we're going to show you how to use some of the more specialized tools. A lot of other companies aren't doing anything with post-tension that we're aware of, and we think we have a really great tool for that. Before we can begin, we're going to go ahead and create a section along a curve. This is really simple. You just simply select the curve that you want to follow, choose the direction that you want to view it from, and you get your nice section along a path there. In this path, we can begin to find some vertical curvature that we're going to use for our PT duct. This time we're just going to do it freehand with the spline, putting it at the top, at the ends where we have negative moment, and then at the bottoms where we have positive moment, and just kind of, like I said, freehanding this. Of course, if you're doing this in production, you would want to have some control points to follow for your spline, but here for the purposes of demo, this is good enough. It's kind of interesting that in the beginning we start with a horizontal curve, a vertical curve, and we combine them up, and then when we go to do PT, we're essentially taking our horizontal curve, applying a new vertical curve in order to get the geometry for the PT duct. But it is really just the way that makes sense when you're operating on it. You have your bridge, and then you're going to want to reinforce it later, and you don't know what that vertical curvature looks like until a little later in the project. So what we're doing now is that we've identified that curvature. We're going to export this to a file on disk. But before we can do that, we're going to want to discretize it into individual points. One of the benefits of ALLPLAN typically is that all of your shapes, your splines, your curves, those are not approximations or polylines. Those are actually 3D curves that are controlled by formulas. So when we do volume calculations, area calculations, length calculations, we're using calculus to integrate those. We're not just simply doing a simple summation. But with the case of the PT ducts, it requires special type of information, which is discrete points. So we've broken that up into 100 points, and we're going to export that to a industry standard file format of geometry so that we can import it into our PT tool, which we'll do now. So you can see we have the post-tensioning dialog pop on the left. We go ahead and select our geometry. It creates the 3D spline as we need it. It's now up to us to go ahead and place it. It's handy if you have multiple of these ducts. You can put them in line with a single piece of geometry. And so looking at our animation view, we're able to see that goes perfectly inside of our interior web. This isn't a typical PT duct. You probably have it on the outsides there, but it's good enough again for the purposes of this demo. You got lots of options available to you with PT. Of course, you may not necessarily have that PT duct go into the end of the bridge. You can apply an offset to push it towards the interior of the bridge if you so do desire. And so you just specify that, and you'll see that it actually moves in towards the interior bridge a little bit there for you. On the left, you'll notice there's a lot of options. We'll go back to those in a second and explore them, but first we're going to go and show how you can now we'll show you right now how you can look at some of those options. You can control the trumpet, the spiral, the anchor plates. You have full control over it. It's parametric, it's adaptable for many situations, and it should cover just about everything you need. Now that we actually have the PT modeled, may be the case that you want to go ahead and put some reinforcement in it. That's easy to do again with our sweep command or extrude bars along a path command. Or simply create a section, put it off to the side. We'll model some bars in there. I'm going to skip ahead a little bit. And so it's just as easy as we did before where we place some bar shapes. Here we're going to do a couple open stirrups around that PT duct. It's going to help you with the hoop stresses that you might have in there. So we'll do one open stirrup and then of course mirror it to get one on the other side. We're just creating, again, this is in 2D sections, so not a whole lot of work that you're unfamiliar with. Using your typical mirror commands, drawing bars, nothing special going on here. Now when we do go and actually place this in 3D, they're going to come out coplanar, but we have an option for that, which is the bar offset. You'll see once these things get generated in 3D that they're existing in the same space, which they cannot, obviously. So we'll go ahead and apply a bar offset in the options here. If you just have two bars, it's simply the diameter of the bar, and now they'll be separated by that distance. So you can see they're separated, they're not touching anymore. You can avoid collisions that way, and then run your collision report without having a whole bunch of extra errors on your hands. A little bit about us: we're part of the Nemetschek group. It was formed by Professor Nemechek. That's his picture on the right there. He's been innovating the industry for 50 years. He founded the company in 1963. It's currently headquartered in Munich, Germany. Last year, we reported a sales revenue of $460 million. We currently have 2.3 million users operating in 142 countries, and we've actually acquired 300 of those users in the last year. We are a publicly traded company. We're listed on the TACDEX, and we have a market capitalization of $5.5 billion. Down below, you'll see our 15 strong brands. Some of those you might recognize, like Bluebeam, perhaps Vectorworks, definitely Risa. Maxon is another name. They make Cinema 4D, which is used to make a lot of movies like Polar Express and those Pixar type movies. So ALLPLAN is a part of the Nemechek Group. We're a leading global leader in AEC software, and we have been producing software for over 30 years. We like to say we're Europe's best kept secret, but now we're bringing it to the United States. We provide BIM solutions for not just engineers, but also architects and contractors. We are an open BIM pioneer. As we keep mentioning, we like to work well with others, not just our sister companies, but the industry at large. We have over 400 employees working in 9 countries, and ALLPLAN alone has 240,000 users in 41 countries, and they're all working in 20 different languages. As you can see, we belong to ASCE, NPCA, PCI, and much more, and we attend conventions regularly, so we hope to see you there. Before we end, we're going to look at a few case studies where ALLPLAN has been used. There's a lot of bridges here. Last time we covered a few case studies, including buildings and heavy civils. Here we're just going to cover bridges, some of the ones we covered before, but some new ones you haven't seen yet. First up is the Queen's Ferry Crossing in Edinburgh, UK. It's the longest cable-stayed bridge, 3-tower cable-stayed bridge in the world. It's got a total length of over 8,600 feet. And as you can see in the picture on the right, there's quite a bit of reinforcement that goes into these piers. And the customer reported that they had 0 issues, and it was all thanks to ALLPLAN. They were able to get it into the field, construction field, collision-free, on time. Here's the Tamina Bridge in Switzerland. You may notice this from our white pages and other materials that we produce. It's a pretty straight bridge, actually, but some of the features about it is you can see that Forester rebar in there at the end with the post-tensioning ducts coming in. And so it was a good way to combine up those different things and make sure that you had the space required for both. A bridge in Romania over the Danube River. This is another type of bridge with an exotic cross-section. You can see there we have some unique angles coming in, and the reinforcement was all done accordingly. Here's an overpass in the Netherlands. This time we combined up more post-tensioning with not just rebar, but also we had voids that were inside of there. Another overpass in the Netherlands. This time we're looking at the pier. You can see that it's got a lot of interesting curvatures. And one of the things that ALLPLAN does especially well is we're able to create reinforcing schedules using many regular shapes. So we're not creating a new bar for every part of the cross section. It really helps to cut down on the time involved in fabricating those bars and scheduling them as well. Another complicated bridge working over a complicated environment, demanding complicated reinforcement, but with ALLPLAN it's able to be done quickly and easily. Here's a arch bridge in Germany. This one isn't such a complicated bridge at first appearance, but it's important to note that at the crown of the arch you have a thicker section than you do at the springs of the arch, but with the sweeping tools of ALLPLAN, that was done pretty easily as well. Here's a bridge in Switzerland. This one was interesting. We had post-tensioning coming from different angles and different directions. Pretty difficult to do, but in ALLPLAN, again, the 3D model and 3D approach that they used, the customer was very happy with. Here's a pedestrian bridge. This is a great example where open BIM would be useful. You could model and design this in Rhino using Grasshopper if you want, but that curved glass and all the nice features of it can be done in ALLPLAN with no problem as well. Here's a pier, a cantilever pier in Amsterdam, more PT integrating with reinforcement. A tied arch. This one is interesting. You did a round trip design with a analysis software, and so anytime the geometry was updated, the analysis was in sync, and the details were able to be updated quickly and easily. I just want to provide you with a few more additional resources before you go. We have a bridge modeling step-by-step tutorial available, or should be available soon, on connect@allplan.com. That's also a great internet portal for our ALLPLAN users. We have forums, tutorials, tech support, and much more that you can find there. Additionally, we have a lot of users and power users that are creating and sharing content for fellow users, so go ahead and check that out. You can go to YouTube or LinkedIn and just search for ALLPLAN, or follow me on LinkedIn and you'll see that in my feed often. I'm always liking and sharing those things. To wrap up, I just want to let you guys know that you can contact us with any questions or information or comments to info.us@allplan.com. And I hope you join us for our next webinar. It's going to be titled Advanced Rebar Modeling, Detailing, and Scheduling, and that will be on September 25th at 1 p.m. Eastern. You can register at the link on the screen, or go to our events page on allplan.com and find the registration link there. That concludes our webinar, and I hope you guys have a great rest of your day. Thank you very much.